Software Engineering Radio Episode 80, OSGi with Peter Kriens and BJ Hargrave. Hello listeners, this is Marcus. Just two quick comments before we get started with the actual content of the episode, the OSGi stuff with Bernd and Martin. First of all, remember we are still running our experiment where we want to see whether we can get enough donations so we can keep the thing going without any support, sponsoring, advertisement, or whatever you would like to call this. So please go ahead and donate if you think that's worth it. The other thing is that recently in a previous episode I promised this thing about running an interactive episode with listener feedback and being able to call in. I didn't forget it, but actually we don't have the time right now to do it, and we're focusing on our core competencies. So we'll keep it on the radar. We'll do it at some point, but we're too busy right now with stuff outside of SE Radio. We all have a real life beyond the podcast. So that was all I wanted to say. Now have fun with OSGi and stuff.
In this episode, we will talk about OSGi, and Bernd and I are on the micros, and we have two guests invited, and maybe those guests can introduce themselves. So, Peter, would you start?
Yes, I'm Peter Kriens. I've been involved in the OSGi since day one. I'm currently the OSGi Technical Director and the OSGi Evangelist.
Great. And BJ, would you introduce yourself?
Okay. Hi, my name is BJ Hargrave. I work for IBM in the Lotus division, and I've been involved with OSGi since day two. Peter got there before me.
Yes.
But we've been both working in OSGi for some time. We've worked on Release 1 and 2 and 3 and 4, and now we're up to 4.1. And so I currently chair the core platform expert group at OSGi, which does the sort of central technology of the OSGi specification. And I also currently hold the role of chief technical officer for the OSGi Alliance.
Okay, great. Thank you. So can you explain us what is OSGi?
BJ, you want to do the honors?
Yeah, sure, I'll start. So basically, OSGi is if you will, a layer that you can run on top of a Java virtual machine, and it fills in some gaps that are really missing in normal Java. Right, in Java, you can write your code, and you can have a bunch of you can package them up in jars, and you can put all those jars in a class path, but basically, there's no information hiding or no encapsulation between those jars. Anything that's publicly accessible in one jar can be loaded and used by something in another jar. And when you get to large and more complex applications, you really need, an additional layer of information hiding or encapsulation. So OSGi basically provides that for you. At the OSGi community event last week, somebody coined the term class loaders on steroids, which I guess is a sort of humorous way to think of OSGi. But it really does defines a regularized class loader methodology where each jar file, which we call a bundle in OSGi, has the means to control which parts of itself it wishes to share and make visible to other jars. And so you really have the ability to decide as a programmer which parts of your jar are the public API and which parts are just private implementation details. And so that's sort of at the basic level one of the main value propositions of OSGi, but it provides more than that as well. In addition to that, sort of what we call the module layer, OSGi also provides a lifecycle layer so that you can actually install and uninstall and update these modules into a running virtual machine without requiring it to be restarted. So that's pretty powerful too. And the final thing we have is a service layer. So in addition to all these other capabilities, and which are fully dynamic, we have a service-oriented architecture layer for the virtual machine. So one bundle can register a service. Other bundles can then find that service and then ultimately bind to the service and use it. So it provides a very nice and elegant means for these bundles to share objects between themselves using a nice service-oriented model. So they don't have to be coupled to the implementation details of a service. They just have to know how to look it up via some contract, which in the OSGi Java world is a Java interface.
Yeah, and I think the key things is the dynamics of this all. It really keeps on working even though you install and uninstall applications all in a single VM. And it's a very elegant model to write small, large applications that need some kind of extension model.
Okay. I think somewhere on the website I read that OSGi is a service-oriented dynamic module system or component model for Java. So I think that emphasizes that, right?
Yeah, that's sort of the tagline we're using now, the dynamic module system for Java. So it really gives you those modularity features. But as Peter observed, one of the key sort of values and differentiators of OSGi over other techniques is OSGi is fully dynamic sort of from top to bottom. And that's very powerful too.
Okay. So can you a bit more elaborate what dynamic means? So you have different bundles or components, and then you have different services provided by that components. What means dynamic in that context?
Okay, the key thing about the dynamic thing is that if you have a bundle gets installed. There are primitives to install a bundle, a jar file in the VM, and there are primitives to uninstall that jar file from the VM. So it will not become, it's not no longer available in the VM. Once a bundle is in the VM, it can be started, which means it will get a chance to run. We will call some code in that jar file. And then it gets a chance to register services, and those are the objects that are available to other bundles. When the bundle is stopped, it's no longer available. The framework will automatically unregister all its services, and they're no longer available to the other bundles, and they should remove any references to those service objects. With that model, which in a way is quite simple and elegant, you can map a lot of different patterns that are dynamic. The key example that I always have is, let's say that you make a Bluetooth driver. Then when there is a Bluetooth phone in the neighborhood, you register the Bluetooth service in the OSGi service registry. Then any bundle that is interested in a Bluetooth device sees, hey, there is a new Bluetooth service, picks it up and uses it until it gets an event that that service is no longer available. And there are a lot of different things that can be mapped to that dynamic model. For example, you have a communication interface. As long as the communication is up and running, that service is available. If the communication goes down, the service becomes unavailable. So by taking that dynamic, the dynamicity very serious and building it into the base platform, you're ready to handle a lot of problems that are normally quite complicated to handle and are usually handled quite specifically in software.
Right, and the fact that we engineered the dynamicity into the entire system from the get-go is very important too, because it's not just one layer that's understanding it, it's all the layers. So as a bundle is uninstalled, right, which removes it from the module, its life cycle is changed, it's removed from the module system and from the service layer all in one hit. So this really removes a lot of details from the programmer because it's all handled for him by the framework.
Right. The key thing is that we took this dynamicity. Actually, it was kind of funny because do you guys remember Windows 95?
Yeah, heard of it.
Yeah, well... Well, these guys are younger than we are, I think. So, no, I'm joking. Windows 95 was famous for rebooting. You could change the tiniest little configuration parameter, and then you had to reboot. And it was really annoying. And Windows 95 was quite popular when we got started, and Windows 98, which had the same problem. And the mantra in the beginning was no reboot. So if you look at OSGi, it's not just the framework that is dynamic. And as BJ said, dynamic from the ground up. All the services are dynamic as well. If you change a configuration parameter, it's automatically forwarded to the interested parties. There's only one way to get configuration data, and that is the dynamic model. So we've really tried to take dynamics very seriously. And interestingly, in the beginning, we were scolded for that because people said, oh, that's too complicated and programmers can handle that, and that's too complicated. And what we see now, by taking the dynamics into the architecture from day one, we have a huge advantage over other systems because so many things today are dynamic.
But you still, as a programmer of using OSGi, you still need to be aware of that the system is dynamic, and you need to take care how you write bundles that they behave nicely in the dynamic environment.
Yeah, that's true, and I think that if you wrote only to the sort of the raw basic OSGi API, you might have a lot more work to do to really handle things well. But we've tried to provide other abstractions to simplify that for the programmers.
Well, to be honest, we didn't do that in the beginning. We were taught that by others.
Right, but at least it went, certainly as early as release 2, we introduced the service tracker. Right, so it was observed in release 1 that this is very hard, and so in release 2 we added the service tracker, which basically was a utility class to nicely capture all of the management of at the service layer, the dynamism of services being published and unpublished, and handling all that. And also, more recently, in Release 4, we've seen things like these dependency injection frameworks on OSGi, which further simplify the model. Things like OSGi's own declarative services, things like the Spring OSGi project that's going on now, and there's other things too, like iPojo and Felix. So there's quite a number of different sort of abstractions to ease the burden for the programmer in dealing with OSGi's dynamicity.
Mm-hmm. But sometimes if I talk to people about OSGi, they think about the dynamic behavior of OSGi, that somehow objects in memory are automatically collected or deleted or updated or whatever. And if I understand OSGi correctly, this is not the case, isn't it?
No, OSGi just relies upon normal Java garbage collection. It runs on pure Java, so there's nothing sort of magical about it. It really requires you to do a good job managing references to objects if you want them removed. And so even though you can sort of uninstall a bundle, the framework itself takes care to release its references to things in that bundle, such as its class loaders and class objects or any other objects such as services. But if somebody else happens to be holding one of those references, then the garbage collector is not going to be able to do its job.
Mm-hmm. So I need to take care that I, for example, cut those references myself if another bundle that I'm using goes away.
Right, yeah. So if the bundle has a service and you're using it and you get the service event to release it, it's in everyone's best interest for you to dereference that service object.
But that's, I think, where the value of these subsystems like declarative services, iPojo, Service Binder, Spring OSGi come in. They take care of that.
Okay, so maybe we can elaborate on that a bit later. I want to come a bit back to the basics of OSGi. So where does OSGi come from? And nowadays we're hearing a lot about several JSRs, so 291 and 294, 277. Maybe you can say something about that.
Sure. The OSGi started out as the work of several companies back in 1998, I believe. Peter was involved very early on. He was consulting for Ericsson at the time. And basically the team of people was interested in trying to solve the problem of the forthcoming residential gateway in terms of providing a platform-neutral environment for deploying services onto it. And so ultimately the work that came out of it was temporarily JSR 8, but ultimately went into a new non-profit democratic standards group, which we now call the OSGi Alliance, and continued from there. So Release 1 was put out in, I think it was 2000, and then we've now up to 2007. So we've had 7 years and four major releases have been put out. So we've had a lot of history there.
It's quite a bit of maturity in there nowadays.
Oh yeah, definitely. So I mean, and then if you talk about the other JSRs that you mentioned, I think it was last year or the year before we started JSR 232. That was a Java ME JSR, and that was about bringing a more advanced Java platform to the mobile phone space. At that time, all the mobile phones were pretty much running CLDC with MID-P, and there was a perceived need that a more advanced environment was going to be needed for future phones, and so OSGi was looked at as that environment. And so we, in addition to starting a mobile expert group in OSGi to work on that effort, simultaneously JSR 232 was formed by Nokia and Motorola to also, within the JCP process, create a JSR to also capture that specification. And so that went final. Subsequent to that, we also started JSR 291 for similar reasons, to bring the OSGi specification to the Java SE space. And also around that, you mentioned, I think it was 277 and 294, which are also related. Sun is was the spec lead on both of those JSRs. 277 is also looking at a module layer for Java. similar to what OSGi provides. And 294 is a language JSR looking at adding some additional capabilities at the language level around information hiding to address some problems that exist. So those are I think that's sort of the basic landscape for the set of JSRs that are out there. I think the goals of JSR 277 are slightly different than OSGi in that they're mostly looking at a static model versus OSGi, which is very much focused on and has always delivered a dynamic model. And the other thing about 277 is that their intent is to sort of provide it as a basic part of Java 7, and whenever that comes out, I think it's 2008 or something. So there are some issues to be dealt with there, and I know Peter is well known, has got a very popular blog entry he wrote detailing some of his criticisms of the early draft of 277.
Okay,
Yeah.
so 294 is called the super packages JSR, just to mention.
Yes. It's basically a language construct to define modularity in the language.
Okay. So can you say that 294 and 277 together are OSGi?
No.
So the super
no,
packages
no.
and the Java module system?
Not at all. Those JSRs have made some effort to separate themselves in that they each have a goal to operate without the other. So I think certainly from 294 is they've been pretty explicit that 294 should function in the absence of a module system, and I'm not sure, but I think the same is true of 277, and that it doesn't require 294.
Right.
But clearly they'll want to work together, but without necessarily requiring each other. So in that case, the sum total doesn't equal
No,
OSGi.
absolutely not. 294 is just a language construct. So if that comes out, then OSGi will support it 100%, and that will be transparent. 277, there is a huge overlap. 277 has a repository that OSGi kept out of the specification, and they include that. And on the module layer, as BJ said, they're addressing the same problem, but they do it in a way that is, in my opinion, a bit disappointing, because it's even less than our release 1. What they're addressing with their dependency model. The dependency model is pretty poor.
Okay. OSGi is just for Java, right? Or are there other implementations for other languages such as C#?
OSGi is grown up with Java. We leverage Java to a large extent. So currently there is a real need for the Java VM at the bottom. However, we are talking currently in the Enterprise Expert Group to allow OSGi applications to more easily talk to other environments like .NET. And there is an effort which with the working title Universal OSGi, but we have to find another title for that, which will allow you to integrate applications, OSGi applications, but they can actually run in another execution environment. So you will have a similar or equal management model, and you will be able to talk to them. But that is still very early work. There is no concrete evidence of this visible. But that's one of the things we're talking about. We really like to communicate with those other environments and integrate them more closely.
Right, OSGi it's built on top of the back of the great dynamic nature of Java, and so we exploit that to the nth degree, which is one of the reasons OSGi can be so dynamic. And some of these other environments, of course, to a lesser degree, have the ability to support that level of dynamics. So it's hard to sort of map 100% of OSGi's capabilities onto other environments like
And of course,
CLR.
if you go to environments like C and C++, you have the whole security issue.
Mm-hmm. So what do you think? Where does OSGi? Where's the future of OSGi? So I heard a lot about these mobile phones and embedded devices, and I also read something about the enterprise expert group. So it sounds more like the OSGi moving towards the server side, application server area, or whatever. So can you give us some insights?
Yeah, the term I really like is universal middleware. If you look at how we build applications nowadays, then you see they're more and more componentized. The open source movement has brought us some tremendous value by delivering large subsystems where we build our applications on. However, if you look today how these things need to be integrated, then you find that it is not always that easy, and they don't really always match up very well. I think that's really the where OSGi can play an intermediate role. If you deliver your code as OSGi bundles, then they will work together through the service registry. So the boundaries between these different subsystems is much, much, much better defined than in normal Java, where you cannot hide any packages. So your implementation code is just as visible as your API that you want to expose. There is no dynamism that if you have certain things, there's no plugin model in Java that works very elegantly, and the OSGi is basically a big plugin model. So I like the word universal middleware because it really describes this idea that you have middleware that will run anywhere from a mobile phone up to an enterprise server, which is becoming more and more important because many enterprise applications or enterprises want to make software that runs, for example, on the server, but also in the mobile phone. So you can run your business logic in different places.
Right.
We had a very interesting presentation in Germany last week where there was a company that actually did that. They had a possibility to edit the configuration parameters of a device in the network, and they could move that code with OSGi bundles to different clients.
Right. So the fact that OSGi, as we mentioned before, comes from an embedded heritage, which actually is a value point as we move into the enterprise space, because it's already small and lean, and it's always easy to move up, but it's always hard to move down. So I think that in terms of the future of OSGi, it's going to be, I think, a valuable technology no matter where you're deploying Java. Right. As long as you're not CLDC, you basically can run OSGi in any Java environment, and the values are important to everybody writing Java code.
Right, and I think that the big thing is it will allow you to know if it will run or not. The big thing with Java is, of course, you can write a piece of code that runs on all these different environments, but the metadata is not defined in standard Java. You don't have the management system that can decide, well, this will actually run on that device or not. And I think that's really where OSGi comes in. It creates a complete, well-defined specification that allows you to deploy that in all those different environments in a reliable and a controlled way.
Sounds pretty much like you can use OSGi for any kind of Java application. Is that right?
Yeah.
If you can run Java, OSGi, in my mind, is a no-brainer.
Right. So
okay.
Yeah. Any non-trivial Java application that's got more than one component to it is a perfect opportunity to exploit OSGi.
And if you take one of the open source implementations, like, for example, Felix, that's only 250K. So we're talking about a relatively small layer that gives an incredible advantage for reliability, ease of software development. We had a guy from BEA on a previous conference, and he said that we thought we were working modular until we started using OSGi. And then they found out that they had lots of coupling that they were not really aware of, and they found out by using OSGi how to do this better.
Can you give us examples where OSGi is already used today?
I guess the most popular example that everyone knows of, is Eclipse, right? OSGi is the plug-in model for Eclipse. When they went to release 3, they were able to successfully perform open heart surgery, discard their sort of bespoke component model, and then sort OSGi in. And so everyone who runs Eclipse, whether it's the IDE or any other Eclipse application today, they're using OSGi right in there.
Well, and then, of course, we got BEA with the micro-kernel architecture, JBoss, that changed their micro-container to support OSGi. There is IBM WebSphere.
Right, there's a lot of work going on in the enterprise space, certainly. People are moving to it. There's a lot of, I think a lot of people are using it. It's not so well known in certain applications, but it certainly is being used in more and more places, I think. But certainly Eclipse is the most obvious and sort of very well publicized example.
That's the big gun.
But as Peter observes, people are starting to use it in enterprise software like BEA with their MSA architecture. They just released a new product. I think it's called WebLogic Event Server or something like that, and that's basically a completely from the ground up, OSGi architected system. They use their MSA architecture and all the parts are OSGi bundles and plug into it. So that's very exciting.
Yeah, and what for me is the most exciting is that I do quite a bit of consultancy, and you get into companies that you never heard of, and they do the most fantastic things with OSGi. I was at a company a couple of months ago that were doing X-ray diffraction machines where they used RFID to detect the components that were used for the diffraction analysis. They get a bundle depending on the RFID, and together they create the system that does its job, using the dynamics completely and all the possibility of OSGi. And there are hundreds, or maybe today even thousands of companies that have a relatively small market, are not visible, but are applying OSGi and having a great advantage with it.
Okay.
And it sounds, if you talk about OSGi as some kind of middleware for let's say every kind of Java application, sounds like there might be conflicts with existing middleware components like application servers or whatever. And if I heard some kind of class loading and stuff like that, can you elaborate a bit on this kind of how OSGi works together with these kind of containers and existing middleware stuff and stuff like that?
Well, I think there's a couple of ways you can think of it. One is that OSGi provides a platform for middleware, certainly, and you see that when people actually are implementing their application servers on top of OSGi. For example, BA's MSA architecture, IBM has put out its Web3 application server, that the products themselves are implemented as a set of OSGi bundles. And so that really doesn't impact, I think, the class loading structures of the applications themselves, but I think that's where the next challenge comes, and it's certainly one of the areas that OSGi's enterprise expert group is looking at is, for example, like Java EE defines basically a certain class loader structure for the applications to deploy into, and that's different than the OSGi class loading model. So there's certainly some areas where we in the community, OSGi and Java EE, need to look at how to make those technologies work better together, and that is a major piece of work that the enterprise expert group is going to look at.
But interestingly, if you look in practice at the moment, it works quite well together. A lot of people using OSGi in the bottom, but actually there's a servlet bridge that allows you to use OSGi inside a application server. So you can use all the advantages of OSGi and still get deployed in the normal way in a large-scale application server.
So you can implement your enterprise Java beans, your web applications, and all those kind of server-side components using OSGi?
Yeah, well, I think there's a Spring OSGi project where Spring Interface 21 used OSGi, or has built a specification to use OSGi in their framework, which allows you to use all the Spring APIs to implement J2E applications. So there's a lot of choice. The thing is that OSGi, if you look at it, it doesn't really do that much, but it does it terribly well. And it tries not to touch anything it's not supposed to touch, which means that you can combine it in an amazing number of ways. And it stays out of the way.
Right. I think the Spring story is a great example of that complementary nature. Right. Spring framework has been very popular for some time and is gaining in popularity, but they sort of Interface 21 started seeing requests from their clients about how do I make this work with OSGi, and OSGi was a complementary technology. It provided things that Spring didn't provide, and I think the Spring OSGi project is going to be very interesting for people to look at because they get the benefits of Spring and OSGi without really having to do anything significant to their applications.
So the main thing which Spring, or the combination of Spring OSGi brings, is that you have a separation between your components, right? And you can use one component in several versions at the same time.
Yes. Yeah. So you get the benefits of the OSGi modularity and its ability to support multi-versions.
Okay. So there are two reasons why to deploy an OSGi application. The one thing is the service-related stuff, and the other thing is the component model.
Yeah. Yes.
Can you tell us a bit more about these kind of different versions deployed to the system? So it sounds like you can deploy different versions of the same module in the same time, or updating from one version to the next version while keeping the VM running. Is that correct?
Well, one of the, as we were working on the Release 4 specification, one of the important requirements that came up, certainly in particular from the enterprise space, is the ability to have a controlled migration, from one version to another. So it's quite often that people have deployed some application. It's composed of a set of components, and they want to deploy a new application. Well, if they want to share one of these components, they might have an issue because these two different applications, for whatever reasons, require different versions of some component that they have in common. And so we put support in release 4 to enable a component to be deployed sort of multiple times at different versions. So I can have, component 1 or component A at version 1 and component A at version 2. And then the information in the manifest that controls how the OSGi framework does its class loader connections will wire up the applications to the right version of the component that they need, and so you can deploy then both applications at the same time because the multi-versioning support lets that happen.
And this is actually implemented in the available open source project right now?
Yes, yeah, because it's release 4. It's a requirement for release 4.
Oh, okay.
Yeah. So that's available, in all the open source, Equinox, Felix, Knopflerfish, they all will support this multi-versioning support.
And it's really important because in the industry, as I said earlier, we're getting more and more open source projects that we take from the net and we put in our applications. And these open source projects not always require the same version. So with OSGi, you can actually still use libraries. For example, you need Hibernate, but one subsystem requires Hibernate 2 and the other requires Hibernate 3. And they can actually just reside in the same VM and on a certain level collaborate, even though they will use different Hibernates in the bottom.
But can they share objects between each other?
As long as they're not from Hibernate. For example, if one application gets a Hibernate 2 object and passes it to the other application, which is wired to Hibernate 3, they'll get a class cast exception. So as Peter said, as long as they're just using Hibernate at the lower portion of the application and they share higher level abstractions, that's fine.
Right.
But you still have issues. There's no magic here. It's just that if you have a class object, it needs to be shared by the same or created by the same class loader if you want to share them across two applications.
But that's why it's also important that's why the service layer is very important, because the service layer is completely aware of these issues. And if you have a service object in a service registry and it happens to be not consistent with your class space, then you will not be able to see it. Well, you can see it, but you have to do some more work to see it. Normally, you will not see it. So you can only get wired up to services that are compatible with your class space.
Right. So there's another example of how all the layers are nicely coupled together to provide, simplifying worldviews for programmers.
Seems like OSGi makes me think a lot more about these kind of how to componentize my application, what types to make public, what types to make private. What types to share between components, what is a real published API, and at least makes me think more about what is the architecture of my system.
Right, because it gives you an additional tool above sort of the standard object-oriented encapsulations. You now can actually encapsulate your components, and so that's really does make you think more about how to properly organize your components.
It's really, I've given a lot of tutorials and courses, and it's really always such a nice view when people start to see what OSGi is. They make their first bundle, and then they start to see the kind of tools they suddenly get in something that is extremely important for their normal work. And I've never really seen somebody being put off by the overhead that you inevitably have. They always like this control that they suddenly get about their own software and reuse.
So if I'm going to start and write my first OSGi application today, what are the most common problems I'm going to run in?
That's a good question. You need to find a good introduction. Neil Bartlett is giving a very nice series on Eclipse Zone, how to get started with OSGi, and I think that's a good introduction. My blog...
Yeah, there's a number of blogs out there, like Peter's blog, and Glenn Normington has a blog, and of course Neil Bartlett. So there's a number of people out there giving you some introductory material, and then it's just a matter of finding some supporting tools. So you can get Eclipse. It's got some support in there through the PDE for bundle programming. Peter Kriens himself has released what he calls the B&D tool, and you can get that from his website. And it provides a sort of a nice sort of low-level tool to package up your bundles, and it gives a simplified view of setting up your manifest. So it's pretty helpful for, I think, beginner programmers too.
Right. It's the manifest. Of course, there's a lot of metadata involved, and the B&D tool basically guesses and calculates the manifest data in a very simple way. It saves a lot of work.
Okay. And so if I'm a bit more experienced and have written my Hello World bundle, are there any other problems I might run into? So, for example, can I use any kind of third-party library without any problems?
No, I think that's the biggest problem at the moment. If you are in a greenfield, then OSGi is absolutely, without a doubt, a no-brainer. The problem is that because of the fact that Java never really had a good extension mechanism, you see that a lot of bigger subsystems have created their own plugin systems. And these plugin systems are invariably based on class loaders. And most of these people that wrote the plugin systems just solved their own short-term problem. They didn't really think about the bigger problem of how you handle these different things together.
Right. They also made assumptions about the structure of the class loaders,
Yes.
right? That they're hierarchical and some other things which are different than the OSGi's sort of more graph-oriented arrangement. So I think it's not so much that they use class loaders, is that they made assumptions which were sort of rather limiting assumptions.
Well, and anyway, the fact that they were building an extension model, which means that we have hundreds of different extension models, pollutes the whole landscape, and they're not always compatible, so you get incompatibilities. And we're currently working very hard for release 4, for the next release, after release 4.1, to see what we can do to make existing libraries play nicer than they do today. But yeah, there is definitely work involved.
Yeah, so I think there's two main issues I see in people moving, for example, existing code onto OSGi. One is this class loader issue we talked about. People, I think, making assumptions about the class loader structure and doing their own bespoke plugin models. And I think the sort of more difficult issue, which is frustrating to people, is that if they have a set of legacy code and it's never been in a module system which enforces modularity, they'll ultimately find that there's a lot of sort of spaghetti that they have to tease apart, and that can be quite a bit of work. And so I think that's another major off-putting thing that people have.
Okay.
Yeah, the biggest mistake you can make if you start with OSGi and you got your 600,000 line system, and you think you're going to break that up in 40 different bundles and be happy. Modularizing existing code is not always easy.
Okay. So the modularity on the one hand is an architectural thing which I have to handle in my application. The class loader stuff is another problem because most often it occurs in third-party libraries, right? Can I handle that somehow, or is it a showstopper?
Usually there are solutions, and as I said, in the next release we're trying to find some common answers to the problem so that it will be easier to solve. But one of the nasty ones is Hibernate, and there are solutions to that. The problem that I find more is that some of the real, if you can make a grassroots application, then the OSGi model allows you to do some really, really elegant things. And the existing libraries just don't really play that well because they were grown up in a more monolithic application world. So I also think it's just a matter of time. In a couple of years, more and more libraries will actually have discovered this model and will have used it and play nice in that more modular world.
Right. Yeah. Hopefully, as OSGi continues to be successful and people continue to adopt it, that over time, hopefully, we'll see these third-party libraries, spend the effort to make themselves work well in the OSGi space, and then this won't be as big an issue in the future.
Yeah. Look at Spring. They adapted all their library, or they are adapting all their libraries to play nice in the OSGi world. So that will be, for the enterprise world, pretty important.
Are there other things which might occur or cause problems, for example, due to the dynamics of OSGi?
Well, I think the things like iPojo and declarative services and Spring OSGi basically take care of that problem quite well. Of course, you have to be aware of it, but my experience is that people actually love it because they see the real world out there is dynamic. It is a dynamic world, and trying to make a static program usually doesn't always work that well in practice as well. So I think the dynamics are usually embraced by the programmers as something they say, hey, wow, this is really cool. And suddenly a lot of dynamic things in the real world can be mapped on this service model, the dynamic service model. So they usually take the OSGi programming model and find patterns in the real world that can be mapped very nicely. So I rarely hear people complaining about it after they have a basic grasp of how it works.
Yeah, I think one other thing that needs to be noticed is that, if you're writing these, quote, static programs, they're often reasonably single-threaded, and people don't have to worry so much about thread safety. But certainly in the OSGi environment, which is sort of very dynamic, you're getting events. They might come in different threads, service events, etc. And so you have to pay more attention to the thread safety of your code. I think in an OSGi world than you might have to in a sort of more flat, single-threaded static world. And so these are sort of little things that can sort of bite you later. So it's important to always, this is true in general, but always to pay attention to the thread safety of your code.
Right. But that is really true in general, because I think most, even the reasonably complicated applications today use multiple threading. It's very hard to do without.
Are there any kind of applications you want to write with OSGi?
Well, I'm having a problem there. I'm working on a command line tool that needs an extensibility model, and I'd like to use OSGi because I think it's the perfect plugin model in the world. I just have to figure out if I can start it up fast enough. OSGi starts up quite quickly, but for a command line tool, you really want it to be able to run immediately. Mm-hmm. So I'm having to do some tests to see if I can get it to run as fast but that might be something that just is a filter. Basically, if you don't have any extensibility at all and the application is quite small, don't use OSGi. Extensibility, or you get a more complicated system, basically more than 10, 20, 30,000 lines of code, then OSGi becomes interesting.
Well, I think it becomes interesting the more components you have,
Yes.
right? If you have a single component system, then it's sort of pointless to have a component model like OSGi. But if you have a set of components and you want to perhaps compose them in a variety of different ways, you really need a system like OSGi. So if you look at these people like BEA and IBM that are building their sort of enterprise software out of it, they're doing it sort of partly, I think, to get the advantages of modularity, but also another significant value to them is that they can recompose these components into new products quickly.
Yeah.
Because they put the effort in up front to modularize and componentize them, they can quickly respond to new market opportunities and reassemble their set of components with other components and ship new products.
Yeah, there's a very interesting presentation from BEA. I think it's still on the website of the EclipseCon conference, where the good, the bad, and the ugly, where they basically outline all those advantages, that they had these huge monolithic application servers of 30, 40 megabyte. And they could bring it down to 6 or they could make systems based on the microarchitecture that was 6 or 7 megabyte. So you get a lot more flexibility once you're componentized. It's not always easy to get there, but once you are there are a huge number of advantages.
Hey, I think we are pretty much done now. Have we forgot to mention something?
Well, the thing is that we touched upon it a little bit, but I'd like to make a call to the industry is to take a good look at OSGi and see if you can support it. If you make an open source project, the nice thing about the OSGi metadata is that it is very non-intrusive. An OSGi bundle is a normal Java jar file, so it can be used as you always used it. But by taking the time to see what you have to add, the component model becomes much more a reality. And I think the whole industry has a tremendous advantage if we get a good component model that Group A can make a set of components that I can plug into my framework without having to do a lot of work. So I'd like to call out to the industry to ask, take a look, what are you doing? Are you making components that are usable for other people? Take a look at OSGi and add the necessary metadata. And if people have a problem there that they need some help, then they can always contact me to see if I can help them or get them in touch with the people that might be able to help them in that area.
Yeah, and we've got an OSGi dev mail list that people can get on too, and there's a whole bunch of people out there that are OSGi skilled that can help answer questions and provide advice. And also to speak to Peter's point, if you look at his BND tool, is a great example of a single jar that is both a command line tool, an OSGi bundle, an Eclipse plugin, a Maven plugin, all at once. So it's
an
not
ant
impossible and an ant test. So it's not impossible to write your code to deploy, in environments other than just OSGi, and yet still support the OSGi environment.
Cool. So thank you very, very much for this interview.
You're welcome. Glad to be here.
Thanks for the chance.
Thank you.
Thanks for listening to Software Engineering Radio. If you want to get more information about Software Engineering Radio, or if you want to give us feedback, please go to our website at se-radio.net. You can also contact the team at team@se-radio.net, although we prefer entries in our comments system on the website so other people can see what you think. Software Engineering Radio wants to thank Henning Pauli for the intro and outro music, as well as Libsyn for providing the bandwidth. This episode of SE Radio, as well as all other episodes, is licensed under Creative Commons license. See the Software Engineering Radio website for details.